This is my first video lesson for Unit 5B, the covalent bond. In this lesson, we'll be describing covalent compounds. So go to page 2 in the class packet. For motivation, compare and contrast NaCl, which is an ionic compound, with CH4, which is a covalent compound. And I want you to think which is stronger, a covalent bond or an ionic bond. Learning target. At the end of the lesson, I'll be able to identify covalent compounds and their properties. So homework will be number 1. It'll be a Junipod based off this lesson. So let's compare and contrast ionic and covalent compounds. So NaCl is an ionic compound. It's between a metal and a nonmetal. Sodium's a metal, chlorine's a nonmetal. There's a transfer electron. Sodium loses electrons and chlorine gains electrons. And there's an ionic bond. But CH4 is all nonmetals and they share electrons. So it's a covalent bond. Now for similarities, they both have a complete octet and they're both binary. Covalent compound is when two or more nonmetals share electrons in the bond. So neither atom loses or gains electrons. So there is no ions here. So here's a GIF showing hydrogen molecule. You can see the electrons being shared by the two hydrogen atoms. If you see the word molecular, it means covalent bonding. So covalent compounds are also known as covalent molecule, molecular substance, or molecular compound, or molecular solids. If you see these terms, they are used interchangeably and they basically mean the same thing. Learning check number 1. Which type of bonding is found in all molecular substances? Pause the video and resume once you have the answer. So when you see the word molecular, it means covalent. So the answer is choice 1. Learning check number 2. Which two substances are covalent compounds? Pause the video and resume once you're done. So covalent compounds are between nonmetals. So if we look at choice 2, it's the only one with only nonmetals. The other ones have metals in them. Learning check number 3. Which formula represents a molecular solid? Pause the video and resume once you complete it. So molecular solid is referring to covalent compounds. So which one of these is all nonmetals? That'll be choice 2. So now I want you to determine which of the following are ionic or covalent compounds. So write I for ionic and C for covalent. So pause the video and resume once you complete it. Okay, so here are the answers. So C means covalent, I means ionic. So if you see a metal and a nonmetal, that's ionic. If you see only nonmetals, that's covalent. Now we're going to talk about the structure of covalent compounds. So in order to understand the properties, we need to understand the structure. So covalent compounds are molecules, which are particles. Water is a covalent compound. If you look at the sample of water, notice that the water molecules are not covalently bonding with other water molecules. To compare this with ionic compounds, ions in the crystal lattice have ionic bonds to all nearby ions. However, covalent compounds do interact and attract one another. It's just not with covalent bonds. They attract or interact with one another using attractive forces, also known as intramolecular forces. So I'll discuss this in the next unit. These attractive forces are weaker than covalent bonds. Check of understanding number 1. What happens when water undergoes a phase change, for example, melting? So you're basically breaking the attractive forces. You're not breaking the covalent compound. So when you break these attractive forces, the water molecules can move away from each other. So now we can discuss the common properties of covalent compounds. Covalent compounds may be solid, liquid, or gas at STP. They are molecules, not crystal lattice. Covalent compounds have low melting or boiling points compared to ionic compounds. Why is that? If you analyze the structure of ionic and covalent compounds, in ionic bonding, the ions in the crystal lattice interact with each other through ionic bonding, but in covalent bonding, the covalent compound interacts with another covalent compound through attractive forces. Those attractive forces are much weaker than the attraction between ions. So it's much easier to break an attractive force than the ionic bond. less energy is needed to break the attraction. That's why the boiling point of covalent compounds are much lower than ionic compounds. We will discuss this in detail in the next unit. Covalent compounds are poor conductors of electricity. They are not an electrolyte. If you recall, an electrolyte is when a substance dissolves in water and conducts electricity. Why don't covalent compounds conduct electricity? In order for anything to conduct electricity, you need moving charged particles. There's no charges or ions in covalent compounds. Therefore, they cannot conduct electricity. The next property is because they're brittle and soft. Why is that? Because attractive forces are weak. For the last property, they are not malleable or ductile. Why is that? Because covalent bonds do not allow the atoms to move. So these are the common properties of covalent compounds. Now I'm going to discuss properties of a special case. So this is known as a network solid. Think of it as like a covalent crystal. It's basically a chemical compound or element in which atoms are covalently bonded continuously throughout the material. So you'll see this in a diamond or in glass. This diamond is basically one molecule, also known as a macromolecule. Macro means big. So in a network solid, there is no individual molecule. There's only one giant molecule. So this is analogous to the crystal lattice in ionic compound. On the regions, you just need to know that diamond and glass, SiO2, silicon dioxide, are network solids. So since they have different structure, they have slightly different properties than a covalent molecule. Whenever you think of the properties of network solids, just think of diamond and glass. Both diamond and glass are hard, they have high melting and boiling point, and they both are transparent. Network solids are similar to covalent molecules in that they have covalent bonds and they're poor conductors of electricity. Learning check number 1. Which characteristic is a property of molecular substances? Pause the video and resume once you complete it. So molecular substances have low melting points. A certain substance is a poor conductor of electricity and has a high melting point. This substance is most likely what? So this is describing a network solid, because a network solid does not conduct electricity, but has a high melting point. So which of these is network solid? That would be silicon dioxide, which is glass. So choice 2. Learning check number 3. Which substance is a network solid? Pause the video and resume once you're done. So network solids have low melting points, so 2 is wrong because the melting point is too low. Network solids do not conduct electricity, just like covalent compounds. So 1 and 3 are wrong. So the answer is choice 4. Network solids are not soluble in water. Think of diamond and glass. Diamond and glass will not dissolve in water. Which is generally stronger, ionic or covalent bond? So here I have a table listing out the typical bond energies of ionic and covalent bonds. If you recall from the previous unit, bond energy is the amount of energy it takes to break a bond. So the more energy you need to break the bond, the stronger the bond. So based off this table, ionic bond is the stronger one. So why is that? The attraction between charged ions in an ionic bond is stronger than the attraction between shared electrons and the nuclei in a covalent bond. So this concludes the video lesson for today. Remember to do the Junipod homework.